Hello and welcome to this video on composite functions. So first of all, we can see here we've been asked to find a simplified expression for f of g of x. Now f of g of x is a composite function where the g function, which in this case is x squared minus 2, is actually embedded inside the f function. What that means is that everywhere in the f function that x appears, we're going to replace it with the whole of the g function. So let's see how that actually looks. In this case, f of g of x means replacing x in the f function, so here, with the whole of the g function. So instead of having 1 plus 2x, we're going to have 1 plus 2 lots of, and we'll need to put it in a bracket because there's more than one term, x squared minus 2. So that's the important bit there, that we've managed to put the g function inside the f function. Then we would want to try and simplify this. The question asked us to find a simplified expression, so it's important that we remove any brackets and to try and simplify the expression as far as we can. So in this case, we're going to have 1 plus, and we can multiply the 2 across this bracket to give us 2x squared minus 4. And the last thing to do will be to combine the number terms here to give us 2x squared minus 3. And that is the end of the road for this one. That is an expression for f of g of x, a simplified expression. So we do have another one of these to look at. A little bit more complicated, this one, because we're actually asked now to leave our answer as a single fraction. There's quite a lot going on here, so let's see what we need to do. First of all, it's g of f of x this time, so the f function, which is the whole of this thing here, is going to be replaced into the g function where x appears. So we can start by filling this out. G of f of x sees us taking the g function, so 3x plus 1, and instead of having 3 lots of x plus 1, we've now got 3 lots of the whole of the f function plus 1. Now the f function was that thing, that fraction itself. Let's not forget to add on the 1. So that instead of 3x plus 1, we've now got 3 lots of 1 over x plus 1 plus 1, which looks a bit complicated, but we can definitely simplify this down. The first thing to do would be to multiply that fraction by 3. So the numerator will change. 3 lots of 1 over x plus 1 becomes 3 over x plus 1. And in the same step, I'm going to rewrite 1 here. Now you know that anything divided by itself is 1, so we can rewrite 1 as anything we want over the same thing. And in this case, I'm going to write 1 as x plus 1 over x plus 1. So it's important that you realise that anything divided by itself is 1. So that's just the same, it's just a version of 1, another way of writing 1. But why have I chosen to write it like that? Well, now what I've created, of course, is a common denominator across these fractions. So I've chosen the denominator to match the one that was already there, which will now allow me to add these two fractions together. 3 over x plus 1 plus x plus 1 over x plus 1 gives us 3 plus x plus 1 all over x plus 1. So we've added those fractions together using that idea of common denominator. Now, we're not quite finished. We were asked to leave our answer as a single fraction, and so we can do that. Well, we have done that, but we need to simplify it by just combining those number terms on the numerator to give us x plus 4 over x plus 1. And that is the end of that example.